Welcome students. Last time we have discussed about classification of crystalline solids. Today I have come with a new video on the topic imperfection in solids. So before we deal this topic in detail, let us know that what does the term imperfection here means. So students, we have already studied that in an ionic crystal, same unit cell repeats in the entire crystal, but in actual this is not possible. This is possible only at 0 Kelvin and at temperature other than this temperature. Such a three-dimensional regular arrangement does not exist, and the reason being very high packing of crystals or granules in solids. Practically speaking, perfect crystals do not exist. Even the best crystals contain 1 parts per billion defect, and these defects are classified as point defect and line defect. Point defect, it is the irregularity or deviation from the ideal arrangement of the particles around a point or atom in a crystalline solid, while the line defect is the irregularity or deviation from the ideal arrangement in the entire row of lattice points in a crystalline solid. Above diagram represents all type of defects present in the crystalline solid. In ionic crystals and in non-ionic crystals. In non-ionic crystals, there are 2 types of defects: interstitial defect and vacancy defect. In ionic solids, there are basically 2 types of defects: stoichiometric defect and non-stoichiometric defect. Rises of metal excess, metal deficient, and impurity defect. Let us take one by one in detail. The first defect is vacancy defect, which occurs in non-ionic solids, and it is also called as thermodynamic defect, as it also occurs when such crystals are heated. It comprises of vacant lattice sites, which results in the decrease in the density. Another type of defect found in non-ionic solids is interstitial defect. In this type of defect, the particle occupies the interstitial sites. This type of defect results in the increase in the density of a crystalline solid. These are the compounds in which the cations and anions are in the same ratio as indicated by the chemical formula. Schottky defect is a type of stoichiometric defect in ionic solids. In this type of defect, equal number of cations and anions are missing from their places. This results in the decrease in the density of the solid, and secondly, but as far as electrical neutrality is considered, it is maintained. Such type of defect occurs in the solids where the cations and anions are of nearly equal sizes. This is the first factor, and the second factor is that the coordination number of such solids is high. Another type of stoichiometric defect is Frankel defect. In this type of defect, the particle gets dislocated from its lattice site and occupies the interstitial site. In this type of defect also, the electrical neutrality is maintained, and also the density does not change. This type of defect occurs when there is a considerable difference in the sizes of the cation and anion, And secondly, when the compound has low coordination number. Now we shall talk about the first type of metal excess defect, and this first type of metal excess defect is anionic vacancy. This type of defect arises when the compound like NaCl is heated in the vapor of sodium. In such a condition, to maintain the electrical neutrality, the chloride ion from its lattice site gets dislocated, leaving the electron behind at the lattice site and moves to the surface and combines with sodium atom which is present in the sodium vapors to form NaCl. The electron left at the anionic site absorbs the light and moves to the excited state, and on returning back to its ground state, it emits a light of a particular color or particular wavelength. That's why this anionic site is called Farbin center or colored center. Now we shall talk about the next metal excess defect, in which there are excess of cations, and these excess of cations are due to the escape of the anion in the form of a gas. For example, in zinc oxide, when the zinc oxide is heated, then the oxygen escapes out, and the zinc ion and the electrons, they occupy the interstitial site. Such type of crystalline solids act as semiconductors, as they have free electrons, but not like the metals which are the conductors. Now, in metal deficient defect, we will talk about cationic vacancy. There are some compounds which are non-stoichiometric, that is, the ratio in which the cations and anions are present, it does not follow the chemical formula. In such compounds, the cation is always short as compared to the anions. For example, in ferrous oxide, the ferrous ion is between 0.93 to 0.96% as compared to oxygen. Therefore, this can be called as the cationic vacancy. To make up the vacancy created by the cation, the ferrous ion loses electron to form ferric ion, and this takes place throughout the crystal. The ferrous ion gets converted into ferric ion, and the ferric ion gets converted into ferrous ion. This continuously takes place. That's why due to the presence of the electron, such minerals, such crystalline solids, they shine, and therefore they are also called fool's gold. This type of defect occurs when the crystalline solid contains some impurities, like in sodium, like molten sodium chloride contains some impurities as strontium chloride. So strontium ions, they displace two sodium ions, and one of the strontium ion occupies the place of one of the sodium ion, and the other place of the sodium ion remains vacant. This increases the conductivity of the solid.